Welcome back to video number 7, UEFN Optimization by GameDevMicah. You can hit me up on Twitter as GameDevMicah, LinkedIn as Micah Berninghausen, and Discord as GameDevMicah as well. If you need to shoot me an email, it's GameDevMicah@gmail. Alright, let's look at level construction. So I recommend building your static cannot be built on level geometry out of a default actor class and adding a single or multiple static mesh components to it. Those static mesh components could be that a static mesh, an instant static mesh, or hierarchical static mesh, preferably. Reparenting this actor to a Fortnite static mesh class will allow you to build on it if you need to, but not interact with it. This is the cheapest option for being built on with the collision profile of Fortnite static mesh. Now that collision profile stuff, there's a lot of them, and there's lots of different reasons for them. And I don't have that all figured out yet, so I'd love some feedback on it, and definitely take a look in there. Less is best. If you don't need a Fortnite static mesh collision, you can get what you want out of it, then try to do that. Let's go through the settings on, I think this is an actor. Yeah, might be the static mesh of the actor. So first thing is mobility. In Unreal Engine, we can do static lighting, but in Fortnite we cannot. So these 3 different mobility settings here help us to try and cache different things like physics and in the system, because Unreal Engine tries to say, okay, this mesh is marked as static or stationary. It shouldn't move that often. If it hasn't moved, save it. Save the details and don't recheck. So the more you can get this to the left and still get your functionality, which probably is plenty for static environments or things you're just looking at that doesn't move, putting it static's the best idea. Enabling gravity in physics, that's an erroneous setting that was back when physics was enabled in Fortnite. Once it gets enabled again, it will mean something, but until then, I would disable it because we don't use it. Anything we don't use, I disable so that there's no consideration of it. Simulating hit events. If you're not using hit events, disable that. It costs. Generate overlap events. If you're not using that, disable it. It costs. The collision preset, you want to set this to the cheapest option you have. Fortnite static mesh blocks a lot of stuff. There may be cheaper options. Up to you. If you set this to no collision, that is the cheapest option because it won't be considered by the collision system. But your player will be able to walk right through it. They won't be able to jump up on top of it. If there's something that they are okay with that happening to, like maybe the lights in a room, you're okay with the player being able to jump through the lights, turning off a collision preset to no collision, that should help make it cheap and reduce calculations. CCD, continuous collision detection, is also an erroneous setting. I would leave it disabled. That back from the physics system. What CCD would do is make sure every frame that this actor is considered for collisions, that it's never cached. So it's very expensive if you're simulating physics, which we cannot do right now. So both enable gravity and UCCD are not used. I would leave them disabled. Casting shadows. If you can't see the shadow of this object, disabling shadows will make the game run better. So disable the shadows. Affects dynamic indirect lighting. This is shadows from bounced light. So it will make the world look a little less good because the shadows won't be as good or realistic if you disable effects on distance indirect lights or dynamic indirect lights, but it will save you performance by not doing that shadowing. Affects distance field lighting. This is far away shadows. If you disable this, it will make distance field generation faster. You won't see shadows for this device, and it will also make the game run faster because it won't have to do shadows for this device. When you can, disable distance field lighting. Same thing for dynamic shadows. Those are the close shadows when this object is moving or anything. If you don't need shadows for this object, disable them. Will save you. Static shadow. I would uncheck that because there are no static shadows available in Fortnite. So by unchecking it, we'll just get rid of the consideration of trying to do static shadows on this. So it's almost an erroneous setting. hidden shadow. I don't know on that one. I think I don't even want to talk about that one. How about that one? I'm skipping. What, did I say anything in here about it? No. All right. And as we go down here, visible and ray traces, if you can uncheck that, that'd be speed things up. Exclude in WPO is a decent one to talk about. WPO is where you're using the shader to move the mesh in like for grass and trees, or maybe to change the position of the vertex if you're using tensillation or something like that to improve the look of the object. If you disable having to evaluate for world position because you don't use WPO, no movement, no displacement, it's cheaper. It doesn't have to look to see if WPO is used. If you can set a WPO range, so world position offset disabled distance is 0 here, that means that we'll always be doing mesh distance, or we'll always be doing WPO assessment. We should really set this to something like 1,000 or 2,000 or 5,000, so that after that range, we won't look at any WPO anymore. So that's something I don't have in here that I'm going to put in here right now. To exclude ray tracing, disable, exclude decal consideration. A WPO max distance here, like 5,000. Now we have the tile up here. We're talking about H-LODs and how big the tiles are. So that's about 10,000. This is about 5,000. So I mean, I would say somewhere between 5 to 10,000. So somewhere out in this range here, we could probably turn off the swaying of trees and you wouldn't notice it, or the displacement of bricks and you wouldn't notice it, and it would make the shader a lot cheaper and make the game run faster. So somewhere in that, probably that 5 to 10,000 range is where you want to disable the world position offset consideration per mesh or material or actor right here. So set this world position offset disable distance to something, and that will cheapen up the materials past that distance. We talked about effects, dynamics, lighting, and distance fields. All right, so that's kind of like that base actor. So existing level construction simplification. Each actor in your level is considered multiple times each frame for several activities. The fewer actors in general you have, the less workload there will be. Reduction of actors can be done via larger meshes in place of multiple smaller actors. Reduction can also be done with instant static meshes. So that multiple actors, the first part there that we done with multiple actors replaced with a mesh, that's what the H-LOD merge mesh does. It takes all the actors in that cell size and merges them into one mesh and represents it in one actor. If you use the instancing, it will take all those individual meshes and put them into instances together on the GPU and render them that way without creating new meshes. Reduction can also be done, which we just covered. Work in progress. HISM components do not package, but I'm getting reports they do from others. I'm currently validating. ISM components have been tested successfully. HISM, yeah, so I need to do some more work on HISM. I got some reports back. They're inconsistent. I mainly use ISMs because then you only need, it's just more efficient and you can get away with it. So I mainly use ISMs. HISMs do have a need or a reason for use on low-end platforms because they can render less polys in non-nanite. So that's why you'd want to use HISM. So let's work together on and validate if we can use HISMs or just ISMs. In UE55, ISMs are getting the option to do instancing, or rather do LODs per instance. So I think we're going to see a merger, and I think HISMs are going to go away and ISMs are going to be the future here shortly. But that's my thought. All right. Oh, warning, ISM, HISMs are excluded in the memory thermometer as a 550 and may cause a level invalidation in the future if memory is loaded is added. So this is the big worry people have, is that they're too efficient right now, and we think they're being missed in the tracking. We don't know if that's intended or not. So most UEFN props will not instance due to baked non-instance enabled materials, and so can't be used. When building a level with a default UEFN prop, such as the OC Floor 01, we recommend these settings for non-static, non-interactable, yet still buildable on enabled static meshes components, such as floors, walls, and other medium to large static meshes. A scale of 1.0 for the building grid is required. Gravity is erroneous. No need for hits and overlaps. Set the collision to Fortnite static mesh for non-interactable static meshes. Set no collision on small or unreachable objects. And CCD is erroneous. Shadows, or if they're required, enable them. We talked about casting shadows, the distance field, the close distance field, and the static shadows. Disable what you can. Same thing with WPO. We covered this. Maybe I already covered this page. They're about the same settings between the component, the static mesh component, and the actor. So the top one was static mesh. I think I am doing the same thing twice here. Sorry about that. It's weird. Alright, so I just did it twice. HLOD settings down here. You want to include it in the HLOD if you want to have it streamed out. And you can pitch your batching of either batched instanced into ISMs or merged mesh HLODs. And then you have your draw distance you can play with as well down here. Detail mode. The detail mode is a part of the settings, and what you can do with detail mode is you get different options here on when things will be rendered and considered not part of the LODs. I haven't played with it a whole bunch. I just leave it on low because low means it will always render. As you get more and more into performance and tuning it, you might want to turn these things around a bit to have it load out sooner or cull sooner. So I haven't had much with that. Navigation. If a mesh affects the navigation, it will impact the generated navigation grids. So if this is something that you want not to stop an AI, like say a book that's up on a shelf off of the ground that won't ever activate or impact that navigation, then turning off affects navigation saves the consideration of even looking at this mesh. And so it's best to leave it off on things that are okay for the AI to walk through, so to speak. It's part of that optimization piece. This is a key piece of learning here at the 12-minute mark, which is the component cost to the engine. I got this from a decent Epic talk. Like busted up screen, I guess. Well, it was a busted up screen I took a picture of. An actor, which is the base class, the most base class you can use right now, which will be replaced with an entity when we get scene graph. But the actor component itself costs 672 bytes, big bytes, BYTE. A static mesh component, which would be attached to that actor, this would be the basic rendering, is 1520. And what's next important is an instance static mesh component, so ISM. So ISM is about 2.4 kilobytes, where a static mesh component is 1.5 kilobytes. This is just the management overhead of the component, has nothing to do with the cost for the mesh or materials attached to those components. So what you'll see is if you have two static mesh components in the world, there'll be about 3,000 bytes. Where if you have one instance static mesh component, it would be about 2,400 bytes. This means that if you have two static mesh components of the same mesh, and you render them with an instance static mesh component, you'll save 500 bytes. If you had three static mesh components, and you render them as an instance static mesh, you'll save 200 bytes. And that just keeps scaling up to about 20,000, and you'll start to see some degradation on the UE side. But easily to several hundred instances rendered with an instance static mesh will have a huge overhead savings versus using the same amount of static mesh components to render it. And this is the detail on the under the hood storage requirements just to run those components. So it's really good to see that if you only have one mesh in a cell, it's cheaper to do it as a static mesh component. But if you have two meshes in an HLOD cell, then it's cheaper to, and any more than two, and then in all cases it's going to be cheaper to render it as an instance static mesh. So the breakpoint is really two. If you don't have at least two, then rendering as a static mesh is fine. It is as best as you're going to be able to do. And then we have a link here, which is to that video, which is how small open doors can lead to better CPU utilization and bigger games in Unreal Engine. So check out that video. That's where this was scraped from. See, we're at 15 minutes. Let's do some additional notes. Deleting any unused items in blueprints or actors. Otherwise, if hidden, it may be loaded in the memory and impact performance. Hidden VFX like a Niagara system, the materials or sounds that you're not using, everything or anything that's attached to a blueprint is going to be loaded in on that blueprint, even if you have it turned down or disabled. So how blueprints work or devices work currently is that everything will be loaded in. So it's best if you can go ahead and if you have, say, a sound attached to a device, but you don't use that sound, to clear it out, not to set it blank in the device. That should still work just fine. Just and assuming you have that sound disabled and in the device, so it won't play, clearing out what sound would play would make when that's cleared out, let the blueprint not load that asset. So if an asset's referenced by a blueprint or a device, it will be loaded. So if you can clear those values out and it will still package, you have to check and find out, because some things are used and you don't know, but things that are used and you do know you're not using them, you could clear it out and save on the back end. Disabling anywhere when it says affects navigation from the actors, like the can't affect nav, helps if you don't need it to affect navigation. Ensuring CCC disable is sort of erroneous, but you might as well. Ensuring overlaps and hit events are unchecked if you don't use them, also impactful and good. Eval world position offset, if you're not using it, disable eval world position offset check. Will save you there and make the shaders more efficient. And then we also have that distance to disable that we talked about earlier too. Make sure you set a WPO disable distance on the actors. Disabling HLOD or including HLOD on all actors that are VFX, UI, or text, or interaction, or anything that won't be put into the merged mesh. That way it's just not considered when it goes to build HLODs. It's a good idea. Recommended settings for a building prop, the top one, and a building static mesh. Building props, this is the most costly building piece in terms of overall performance. Use as few as possible. Building static meshes is the second most costly building piece. It's less expensive than building props. The play hit damage animation, disable it if you can, because it's just going to do more things. Register structural grid is required for building on it, so you may need to still do that. But if you don't have building, you don't need to register it with a structural grid. Weak spots are the part of the damaging system or that micro game of hit back and forth here. Disable that. And allow interaction. If it's not interactable, don't allow interaction. Team damage, turn it off if you're not going to let it be damaged. Net cold distances, this should affect how fast or how far things replicate in. But if they're using spatial loading, chances are it's going to replicate in and be hidden, because spatial loading might not want to load it yet. So I haven't really found net cold distance squared to do anything. I've tried setting at different ratios. I don't know if it does anything, so I'm not sure there. Include an HLOD. This would be if you wanted to have this stream out and be represented in that merged mesh or instant mesh HLOD. And spatially loaded is also saying if we actually do load it in and out or not, where you could say leave it in and cull it at the HLOD distance. See, we're at 20 minutes. So actor plus static mesh component is what I recommend for anything that you're not destroying or interacting with. If you just want to walk on it or have collisions, it's the most effective way to build something. Actors must be a subclass of building static mesh to be built on. So if you need building on, you'll have to make sure you're part of that, a different class. Otherwise, it will just be collisions. All right, we're at 20 minutes. We'll at page 27. Let's do 28 and onward, the next one. Have a great day. Hope to see you soon.